Welcome everybody to my LeetCode weekly contest 396 live stream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few minutes, we'll be starting contests live. We will be answering questions in the chat. We'll be giving hints in the chat. So come join us and code along with me every weekend for the contest. No code will be shared during the contest itself because it's a contest, but afterwards we'll go through all 4 problems. So stick around after the contest ends to get solutions. If you enjoy LeetCode content, do check out the rest of my channel. I have videos on different problems as well as the hardest problem 4s of previous contests. As usual, like and subscribe to stay up to date on new videos. Alright. The contest is going to start in another 17 minutes. Let me see if who's around. And also make sure that my contest is hey S Vashif, how's it going? Hey S Vashif, how's it going? Hey S Vashif, how's it going? So I code in Python. I code almost exclusively in Python. These days I'm also learning Rust. So I do some Rust programming. But I don't know, I feel like if people want me, I can also code in C++ or Java. What language do you code in as Vashif? Okay, so it's gonna be another 15 minutes before the contest starts, so we have a bit of time. I can't see how many people are live now. It's very weird. Sometimes I can see it, sometimes I can't. I think it has to do with my view settings. Anyway, I'm going to work on some problems. Oh, by the way, I like C++ for object-oriented. I use JavaScript because I don't know unordered map in C++. Unordered map. You mean like a hash map? Most maps are unordered, I think. I don't know the default for C++. Yeah. Honestly, if you know one language, it's not hard to learn the others. It's not hard to learn the basics of all other languages. Yeah, hash maps. Yeah, those are really important. Those are very fundamental data structure. You use them all the time. Even in like normal, non-competitive programming projects, you gotta use them all the time. I feel like it's not hard to learn different languages once you know one really well, because they have more or less the same things, right? There's always some kind of lists, always some kind of loop, always some kind of map. The pointers are going to be different. Like Java has references. In Python, everything is a reference, basically, mutable and immutable objects. In C++, you have explicit references. And if anybody knows Rust is my new Rust is my new favorite language now. It's a very fun language to learn. If anybody wants to try it out, yeah, you should definitely try it out. Mapping LinkedIn list. Yeah. Oh man, LinkedIn list. Pointer-based problem this week contest. Yeah. Well, we'll see where we go. Yeah. Yeah. I actually teach a programming class in the university. I always start with Python for new programmers because it's the easiest to learn. You just learn just what programming is. You learn about loops and conditions, and you learn about execution flow, functions, arrays. You don't have to worry about things like pointers and object-oriented programming yet. Anyway, object-oriented, yeah, linked list. Anyway, object-oriented programming, I think, is going away. I honestly believe that. If you look at new languages like Go, like Rust, even I think Kotlin, many of them use this thing called type classes. So they don't do object-oriented programming anymore. Not in the same style as C++ and Java anyway. You can still learn it, but things will change. Things will change in the future. Yeah. Okay, let me see if I can. Before the contest starts, I'm gonna see if I can just work on the daily problem a little bit. Yeah, weekly contests, because I think it's 8 a.m. in India right now. So most people are still sleeping. So there are very few people who show up for the weekly contest. Delete a node in it. You're given a node to be deleted node. You will not be given access to the first node of head. Wow, singly linked list. How do you do that then? All the values of linked list are unique. It's guaranteed that the given node is not the last node in the linked list. Delete. Value of should not exist in a linked list. The number of nodes should decrease by 1. Or should be in the same order, or nodes after. How do you do this if you don't have... Oh, interesting. Do not return anything. Modify the node in place indeed. Oh, okay. Interesting. So this is today's daily problem. At first glance, I thought it was impossible. Because what you want to do when you normally want to delete, let's say you have this and you want to delete 5, right? So what you do is take 4, you connect it to 1. So that's how you delete 5. But in this case, you are not given the head of the linked list. So you cannot find 4. You cannot find 4. So that's problematic. What are you going to do? So you cannot do this. You cannot like route the next pointer of 4 to this new node 1. So what are you going to do? Well, one way you can do it is, instead of just deleting 5, instead of deleting the 5 node, this circle, you want to delete the value 5. So you replace it with 1. You replace this with 9. And then you delete the last node. So this will effectively be 419. This will effectively be 419. Yeah, this is an interesting problem. So instead of actually deleting the node, which is what you normally do when you delete a node in linked list, what you want to do is you're deleting is the value. So you move all the values up by 1 and you delete the last thing. So this will effectively delete the node. If you look at the physical memory space that they occupy, that these objects occupy, the actual object you're deleting is the last node. But here it doesn't matter, because all we care about when you look at the definition of deleting is that the number of nodes go down by 1 and the value of the given node must not exist in the list. Right? So all it does is check that the values are correct. They don't actually check that the memory address of the objects are actually deleted. Okay, let me see if I can code it up in like 9 minutes. Okay, let me see. For watching, okay. Yep. So normally for weekly contests, there's not a lot of people. So let's see if we can code this up quickly. While node dot next equals none. Let me see. Oh no. If node dot next not equals to none, then node dot value equals to node dot next dot value. If node dot next equals to none, else. Okay, so the first step we do is to copy. So 1, we take this 1, we replace it by 1, and then we check, is this 1 the last number, right? That's what we're checking here. If node.next.next equals none, node.next.next equals to none, then what we do is we say node.next equals to none. Else, we do not, we delete node self, self.delete node.next. I think this should work. Oh, val, not value. Hi, Najimuddin. Can you solve all 4 problems within an hour today? No, I can't. I literally can't. I think I've only done that twice in my entire. Yeah, no, one time. One time in the last. I started this channel about 3 months ago. I've only solved all 4 questions one time. So I'm not the kind of speed runner. Instead, I like to spend more of my time sort of explaining things to people and helping the people in my chat, right? Because that's why you're here. You're not here to watch me perform a miracle. You're here to hopefully learn something. Let me see if I can run this. Hey, yay, great job. Alrighty, daily problem solved. I wanted to use that as a warm-up, but you know, I guess there's not a lot of stuff to warm up. Yeah. Let's make it 2NN today. What is 2NN? Well, you sound very confident, so I'm gonna say yes. Yes, let's make it 2NN, even though I don't know what it is. Yeah. But I know, you know, actually the thing is we're all here to learn, right? The most important part is to get better at programming. So that next time when you apply to job, next time when you want to actually work on your software projects, you're more equipped to do that. What you actually get in like a fake internet contest doesn't matter. You win this contest, you know, you really don't get anything. So don't worry about that. Yeah, well, yeah. That's like, you know, completely irrelevant. The best you can do is to start a YouTube channel if you're good at this kind of contest. And I can tell you that's not a very lucrative trade. It's better to be good at programming and then actually get a real job, which I hope most of you are going to do. So where am I from? I'm based in the US. I'm on the US East Coast. That's why when I write my contest time, I normally write East Coast time. So it's actually 10:30 at night for me right now. Oh, by the way, does anyone know why there is a Darth Vader on the stream thumbnail today? Does anyone know why I put a Darth Vader? Let me see if I can find it. Let me see if I can find it. Does anyone know why there's a Darth Vader? Star Wars Day, exactly. Yes, May the 4th. So May the 4th be with you for the contest. Yeah, 4 more minutes. You know what? Let me find another problem to work on. Yeah, behold, Darth Vader. bathe in the power of the Force. Let me see if I can find another problem to work on and warm up a little bit. Oh, whoops. We slay today? Yes, we do slay today. Alright. Let me see if I can knock this out quickly. 3 more minutes. This is not part of the contest, by the way. Yeah. Yeah, I did a survey a few weeks back asking people what language they use. I found that most people use C++. About half of the people replied use C++. I might switch to C++, although honestly, if you're preparing to pass tech interview, I still recommend Python because Python is a lot easier. You don't run into small problems. And it's so much easier to do stuff in Python. You know, it's a lot slower. It's super slow. So sometimes when you're doing like actual competitive programming, I found that sometimes my code works, like the big O notation works, but Python itself is too slow and caused me to TLE. But that's quite rare. Most of the time it's fine. Find 3 numbers in sums, nums such as sum is closest to target. Return the sum of the 3 numbers. Okay. Yeah, I think this should be let's see. I think it's probably some kind of binary search. I'll think about it. Okay, so it's 18 seconds. All right. Hey, Rohan Sharma, good to see you again. Yeah, welcome back, and thank you for coming back week after week. You know, it's fun to all do these contests together, right? All right, guys and girls, let's do it. So I'm gonna keep my screen on the main contest screen. If you have problems, make sure you shout out. I don't show my code, what I'm working on screen, because you're not supposed to share answers during the contest. But I will share hints. So ask in the chat if you need help. Okay, first one is not too difficult, I hope. Let me just make sure there are no questions in the chat. Good morning, Praniv. Welcome. Soft one, nice. Good job. First one is not too difficult, right? Oh, it's alpha. Very quiet in the chat today. Good. Sounds like people got first one is pretty easy. Says I, who took a very long time to solve it. Minimum number of operations make words k periodic. String word of size n and an integer k that n k divides n. K periodic if there's some string s such that it can be, wow, this sounds challenging. Okay. Oh, interesting. Oh, I see. Okay. So this is not that hard. All right. Any questions from the chat? No questions from the chat. You guys are slaying today. You guys are really doing well. No questions. If you have questions, need help, ask in chat. Nice. You guys are really kicking butt. Although there is a there's an 8-point question in the last at the end. So that's the final boss. Hopefully the first 3 are easy enough that we have a lot of time for the final boss. Minimum possible length of string T. Third question, what's the approach, Aditya? I'm still working on it. But I'll tell you what is the approach I'm using. So here's what I'm thinking about for third question. So third question, what you want to do is you have S and you have T, right? And so idea is S is a very long string, and then you know that S can be broken down into some multiple. Each of these are anagrams of T. Different versions of T. Right? So what's an anagram? So an anagram means that they have the same number of characters. They have the same the same set of what you call that? The same set of characters with the same frequency, just jumbled up. Right? So you can basically think of T as like you can store it as a dictionary. So the way I'm doing it is basically I'm essentially doing this as a, I want to say like 2-pointer. This is how I'm doing it. I'm going to maintain a pointer here. Okay? So at the first, my pointer starts at 0. So this first pointer points to the end of the first T. And then the second pointer just keeps going on. Keeps going. So every time I move this pointer by a certain amount, like let's say this T here, right? Let's say this is 4. Length 4. So place my current pointer. Let's just call this end. And then this is current. So the way I'm thinking about it is I want to make sure that my current pointer is always multiples of end. For instance, at end, END, I know there's like A, B, B, C. I know 1A, 2Bs, 2Cs. At my current, I need to count how many there are here. There must be there must be exactly 2As, 4Bs, and 2Cs. If I don't see that, then something is wrong. If I don't see that, that means that this is not the right end. I need to move n by 1. And I have to increase this. Okay, next letter is D. Okay, and then now I've moved current to the next multiple of E and D. I need to check that is indeed that number. So that's my strategy. Yeah, that's my strategy. I don't know if it's gonna work, or I don't know if it's fast enough, but that's what I'm trying right now. So I basically do like 2 pointer. One pointer points to the end of the first like sort of segment of T, and then the next pointer just keeps going right. At every multiple of T of this like this T candidate for T, I check that the count is correct. I think this will be linear time if I do it right. I hope that makes sense. I don't know. I think it should be linear time, right? Because your current keeps moving to the right, and your END keeps moving to the right. They never go back, right? So I think it'll be linear time. Not sure. So I'm also still thinking about the problem. I hope that's helpful. Okay, so Chris Din, question 2. So it's good. I like that everybody has no problems with question 1. So Christine, you need help with question 2. So question 2 is minimum number of operations to make word K periodic. This is actually it's not that different from question 3. Now that I think about it, it's a little bit related. So to make a word periodic, right? You have a word of length n, and you have an integer k. So you know that this n, you don't think of this as a word of length n. Think of this as an array. This code lead, think of it as an array. So first thing, you break it up into an array of strings, right? The length of each string is going to be k. Does that make sense? So you break up into an array of strings. The length of each string is going to be k. And then what happens? Now the operation you can use is to replace these chunks, right? This first 4 letters with, let's say, the second 4 letters, right? So you essentially have an array of words, each of length k, and your job is to count how many times I have to run this operation. You know, replace one word by another word. What's the minimum number of times I could run this operation to make them all the same word? Well, you know the answer to that, right? There's 2 leads and 1 code. So how many times do you need to do this replace operation to make all of them the same word? There are 2 leads, right? So let's use the most common one. The most common word is lead. So we'll copy that to all the other words. So you can count how much time that takes. I hope that's helpful. Solve 3. Oh, nice. Very nice. Vashif, you are on a roll. Good luck for the last question. It's a 8-point question. If you solve 8, that would be pretty awesome. I was gonna say I would be impressed with you, but you know, you're not working for me being impressed. Your goal is to be impressed with yourself more than anything else. Hmm. Hmm. Interesting. All right. MD Faizan, you have a question? Oh, that's a previous. Oh, okay. You have a question about question 2? Let me go over it real quick. Question 2. Question 2, you are given a word of length n and an integer k that k divides n. Right? So for instance, a word like this, LeetCode leet, k equals to 4. So the length of the word is divisible by k. So what you want to do is you want to exchange parts of the word. You want to copy parts of the words to other parts so that it becomes the same word repeating a bunch of times. Right? So one way you can think about it, yeah, so this is like example. So one way you can think about it is instead of thinking about word as as a single long string, you can think about it as a list of individual words, each one of length k. So LeetCode leet, k equals to 4, is equals to, you turn it into essentially a array of 3 words, leet, code, and leet. Each one of these words, length k equals to 4. And then now you want to figure out how many times do you need to copy words over each other to make the array the same thing. Well, just count what's the most common one, and you copy that number of times. There are 2 leets and 1 code. So how many times does it take? Well, you have to copy the leet onto the code, so it takes only 1 time. I hope that's helpful. If you have more questions, feel free to ask. Now I go back to question 3. Question 3 is tricky. Yeah, so I'm very impressed that as Vashif, you managed to solve it so quickly. Or maybe you have a better strategy than me. My algorithm seems to be maybe a little bit suspect. Q4, anyone? I've not done. I'm still working on Q3. So let me see if I can. Hold on. Let me see if I can look at Q4 real quick. Q4. So you're given an integer array nums and two integers cost and cost2. You're allowed to perform either of following operations any number of times. Choose an index I from nums and increase nums I by 1 for the cost of cost1. Choose 2, okay. So from nums and increase by 1 for the cost of cost2. Oh, interesting. Okay, so you can either make one of them okay, so you can either make one of them go up by 1 or two of them go up by 1 for the cost of cost2. So obviously cost1 must be higher than twice of cost2. If cost1 is less than less than half of cost2, then you will just increase by cost1 every single time. Okay, so cost2 is normally smaller. Okay, like this one, if cost1 is less than half of cost2, so you always use cost1, you never use cost2. Cost2 will not be better for you. So essentially, because minimum to all elements equal. Let me see. Will they always be the same as the max element? They should always be the same as the max element, I think. Like if the max is 5, they should all become 5. Okay. So you have like 2, 3, 3, 3, and then 5. So you're basically trying to fill in this gap, right? So if cost2, if it's cheaper to use cost2 than cost1, if it's cheaper to use cost2 then do cost1 twice, then what you want to do, I guess what you want to do is pair them up, right? You want to pair them up, right? So let's say these two are the same number. So you want to pair them up. Cost2, cost2. And then this one are different numbers. So you do a cost1 here. And then now you pair them. Cost2, cost2. So oh, is this just a dynamic? Oh, wait. Is this just... Isn't this a recursive problem? So you sort them. You sort all of them. And then you find out what's the largest number. And then you take out the largest number. Right? Because everybody else needs to go up until they're the same as the largest number. So I would, let me see, I would sort them first. And then what you want to do, next is to say, oh, I wonder if this largest, you can't always do this. Maybe you can't always do this. I'm not sure. I'll think about it a little bit. Because you don't always want to reach the largest number, right? Because if let's say you have okay, let's go on this line of thought first. Here's what I'm thinking. You find out what the largest number is. Okay? So my first instinct is you want to get everybody to the same as the largest number. So in order to do that, I would sort them, and then I'll sort of pair them off. Like if these two numbers are the same, then I would. But if they're not the same, then what do I pair, right? So if let's say there's okay, so I can either cos 1 and then cos 2, or I can like cos 1 and then 2, 2, 2. Yeah, not sure. Yeah, basically you want to see if you want to pair them up. I think this should be a dynamic programming problem. So the question is just, do you want to pair this, like for each one, do you want to pair it up or you want to pair with the next one? I think that's the yeah. I'll think about it a little bit more. Yeah. You can use ChatGPT to solve it. I don't know if, I don't know if that will get you banned or not. I have no idea. But you can try it. I'm not gonna stop you. You might get in trouble with LeetCode because if you use ChatGPT and someone else use ChatGPT, your answers will be identical, and then LeetCode will say, "Oh, you copy from each other," which is not true. But yeah. So I don't know how that's gonna work. Okay. Anyway, good luck. Let me finish question 3 first. Or you just calculate the GCD of all the number of words. Yeah, that's pretty smart. Yeah, yeah, interesting. I'm surprised that works. I'm trying 2 pointers. It's not working out for me. So you can try GCD. I would recommend you try that. So I do 2 pointers. So I basically have a left pointer that says if yeah, I basically have a left pointer. But you can try GCD. You know, I'm also gonna try GCD to see if it works. Because I'm not having a lot of luck. I'll explain what I tried. But I don't know if this is really the right way to do it or not. So essentially what I did is I have 1 pointer on here, and I have a current pointer. I keep going. So I start with this. If I think of the length of the word as a number of t primes, a bunch of t's, basically what happens is my n goes to the next multiple of next divisor of the length, right? Let's say I try 4, okay? And then my current would just keep going. I'm going to keep track of all the letters I've seen, and then I check if they are divisible. If all the letters I've seen are basically sorry, let me repeat myself. So I have 2 pointers, one n, end, which is the n of the first t prime with first t. I don't know how long t is, right? So n starts at 1. So I put my first letter inside like a counter. And then my current, I'll keep going to move. And at every time, I want to check that the number of letters, the number of occurrences in this n, end, is divisible by the number of occurrences in current. So if current is like, you know, if end is A, B, B, C, and then my current is like B, C, B, A, and then I'm like, good, keep going, and keep going. Next one, if the next 4 is not, if the next 4 is like, you know, like D, D, whatever, and then I'll just increase and end, move by 1. So this is what I'm doing. I have to say though, I'm not having a lot of luck with it. So if you want, you can try the GCT approach. Yeah. 2 pointer with prefix sum. Yeah, maybe. So yeah, I don't know. I'm kind of stuck too. I don't know if can you really do it with GCD? Because if it's like you just count the number of letters and then you find the highest multiple. What if you all the frequencies? Yeah, I know what you mean. But what if you have something like A B B B B, right? There are 4 A's and there are 4 B's, and your GCD is going to be 4. But you cannot have but T is not 4. Because you, like, this AAA is not an anagram of BBBB. Okay, never mind. That's very interesting. You know what? I'm going to try a GCD. I'm going to try GCD. If GCD works, I'm going to be so angry. Man. Ah. So Legend OM, unfortunately cannot put the code here because LeetCode this is a contest after all. So we can't share answers while the contest is still running. So I'm gonna ask you not to share any code here. You can talk about it, you can discuss. Yeah, you can talk about it. So hint for 4, unfortunately I don't know what's the hint for 4. I'm just as stumped as you. Yeah, I think it has something to do with like pairing numbers up. You want to get to this last number, right? So you want to pair these numbers up. If they're equal, you can just pair them and make them. If they're not equal, then I don't know how. So for instance, if it's if it's something like this, there are 3 numbers. So you can, yeah, I don't know what's the optimal way of doing this. Yeah. So if like the numbers that you have to increase are even, then I think it's quite simple. Just pair them. You just sort them and pair them up, I think. But if there are odd number of these numbers, then I'm not sure what the optimal solution is. So even, right? So even if it's even, you want to get everybody. These are the 4 numbers. 1, 2, 3, 4, 5. You want to get everybody to here, right? You want to get everybody to this level. So you need to. What's the best way to do this? Maybe you have 1 here, 1 cost 1, and then this is cost 2, and then cost 2, and then cost 2. I don't know. I'm pretty sure it's a dynamic programming solution, but I have to think about it a little bit more. Yeah, it should be 8. I don't know. So for so for A, B, what's the expected solution? Oh, whoops. Oh, they don't tell you what the expected solution is. It should be 8, right? Yeah. Yeah, you're right. Yeah, so GCD does work. I'm pretty sure it's not supposed to. Because for A, B, 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 the answer should be 8. If you use GCD, it'll give you 2. So I'm pretty sure it's not supposed to work. But, sometimes it works. If I understand the question correctly, concatenation of anagrams of string T. Minimum smallest length of string T. Yeah. Okay. Anyway. Let's look at the last question. Yeah, let me go through what people are doing for question 3. Okay? And I'm still convinced that I don't think this is the right way to do it. But it works. So basically what you want is you have S that is like this, right? And you know that it forms an anagram. It's a concatenation of multiple anagrams of some string T. So for instance here, if T is BA, then AB and BA are both anagrams. So what some people are doing is basically we want to, how do I say? Okay, if we think that S equals to an anagram, if we think that S is a concatenation of multiple anagrams of string T, right? That means that for each individual letter, if let's say there are like k copies of T, if there are k copies of T in S, then the frequency of each letter in S is k times the frequency of that letter in T. Does that make sense? So in this example, for instance, there's one. Yeah. So there's like 1, 2, 3, 4, 5, 6. There are 6 A's and 6 B's. Okay? There's 6 A's and 6 B's in my example. So this means that there are basically k copies of T. Actually, this is not a great example. Let's say I add a C. There's 6 A's, 6 B's, and 3 C's. Okay, in my example. So if you have 6 A's, 6 B's, and 6 C's, you know that this S is an anagram, is k copies of an anagram of T, and each anagram of T has the same number of A, B's, and C's. So what's the possible value of k? Well, there's only one possible value of k. K has to be 3. There has to be 3 copies of T in S. Because you look at A, B, and C, each of them, the greatest common divisor is 3. All of them are divisible by 3. K cannot be 2, right? If K is 2, well, there are 3 C's. How do you distribute 3 C's between 2 copies? K also cannot be 4. Same thing, how do you distribute 6 A's between 4 copies of T? Such that each copy of T, each copy of the anagram of T has the same number of A's. That doesn't work, right? So the logic is basically that if there are 6 A's, 6 B's, 6 C's, and 3 C's, then K can only be 3, because that is the greatest common divisor of all 3 numbers. Okay? So if K is 3, what is the length of T? length of t equals to length of s over k, correct? There are 3 copies of t. Total length is length of s, so just divide it by 3. Yeah, so I'm pretty sure the GCD is wrong, because just look at this example, right? If I take out the c, a b b a b b a a b a b, okay? If that's my string, if you take GCD, GCD is going to be 6. It's going to say that this string can be divided into 6 copies of t, where each t is 2 letters long, and they are all anagrams of t. 6 copies of anagrams of t. But that's not correct. So this one is anagram, this one is anagram. This is not anagram. These ones are not. BB and AA are not anagrams of AB. These are correct, but some of them are wrong. So I'm pretty sure the GCD method is like somehow it gets accepted, but you know, I don't think LeetCode is doing the right test case here. That's what I think. Okay. So back to question 4. So question 4, 1, 14, 14, 15, 21 output 8, 2, 1 output 8. So 1, 14, 14, 15. In order to get this, yeah, GCD, I'm pretty sure it's wrong, but it's accepted. So what can you do? The test cases are wrong. I think so. Yeah, without answer without GCD, I think it's 2 pointers. So I'm pretty sure you can do that. You have solved it. Oh, nice. So 1, 14, 14, 15, 22, 1. Okay, for the Panchu algorithm. Basically, what you want is it costs $2 to move a number by 1. It costs $1 to move the number 2 numbers by 1. So you're going to first pay $1 to make the 2 14s 15. So you pay $1, you get 1 15 15 15, right? Let me draw it. I have this. Okay. Oh, where do you get that? I don't know where you got that. So it's 1, 14, 14, 15, right? And 2, 1. So you're going to pay $1 to make this 15 and this 15. And then you're going to pay $2 to make this 15. And then you have to pay the $2. Hey, wait. Interesting. Is it the other way around? Two, 1. Well, I'm pretty sure this is going to this to 15 is going to be 14 times this. So I'm not sure where you get 20 from. Yeah, you have to keep increasing the maximum also. You should prioritize cost too. You should definitely prioritize cost too. I'm also yeah, I'm just as stumped as you guys. So question 2. Okay, so question 2, your hint. Somebody was asking your hint of, instead of thinking of this S as a long string, just think of it as an array of many strings. Each string is length k. So you have an array of many strings. Each string is nk. How do you make all the items the same? By replacing. Well, you count what's the most popular item, and then you copy the popular item into all the others, right? So that should be quite straightforward. Okay. Yeah, I'm convinced this is a DP problem. Yeah, I'm pretty sure this is a DP problem. Okay, I'm gonna stop explaining problems. Sorry, I need to work on question 4. The way I'm gonna do it is as a DP problem. I'm gonna sort this. I'm gonna find I'm gonna look at the very first smallest number, and I'm gonna see what's the cost for equalizing the smallest number is gonna be 0. The cost for equalizing the first 2 columns is going to be if of first 2 columns is just going to be cost 1 times nums 1 minus nums 0. And then for I in range 2 to length of nums, subsequent ones. Isn't just this a DP problem? Maybe I'm missing something. Oh, it's a 2-level DP problem. two 1D arrays. It's two 1D arrays. Yeah, it's DP. I think so. So one dimension is n, and then the other dimension is like true false, because you have to keep track of whether the last, like, let's say you're on step n. Let's say you're here, right? You're here. Let me use a different pen. If you're here, you need to keep track of whether the last person had like used a double brick with the person before him. Does that make sense? I think so. That's what I'm thinking. So this is what I'm thinking. First, you sort them, obviously. I don't think you can go wrong. So the idea here is you want to, like DP, you want to equalize from here, like this is 0, 1, 2, 3, 4, 5, right? So you want to equalize up to 2. So your DP table will store how much it costs to equalize up to 2. And the idea is equalize to 2, and then you move up to 3. Yeah. So let's say how much does it cost? Well, there's only one way to do it. You have to use a cost 1, a single 1 brick. So to do here, there's 2 ways you can do it. One is you can use a double brick, or, well, you can also use 2 single bricks. Okay, so you want to equalize up to here. Either you use a double brick here, and then add a single brick. That's the only way, I think. Yeah, I don't know. I don't think there's any better way. Maybe it's not even DP, you know? And then you're going to get to here is just use 2 double bricks. Yeah. That's how I'm thinking about it. Well, as a reminder, don't share code here. Don't share code here, because if you share your code, somebody's going to copy your code, and then LeetCode will discover that, hey, you're copying code, you're cheating, and then my channel is going to get implicated for helping people cheat, right? After all, this is a contest. We're not going to cheat in the contests. And besides, the goal of this is to learn. There are no prizes for winning. There are 0 prizes for winning. It doesn't do anything for you. So the goal is to learn, so it's so much better to learn by yourself. If you want to know the solution, it's okay. Just wait until after the contest. After the contest, I'm going to go through all 4 questions. If I don't know the questions, it's fine. I'm going to release a video a few days later. And, you know, if you're impatient, there are people who are smarter than me. They will release their problems. So, yeah, so bottom line is don't cheat. Yeah, max 21 is optimal. It will give you 20 costs. Yeah, so this is the tricky one. You sort of put the double brick on the 1 and the 14, and then 1 and the 2 and the 14, and then 3 and the 15. You keep adding double bricks. Yeah. Yeah, so this is not... So question 4 is not greedy. If you use greedy for question 4, you'll fail. Yeah. So I tried using DP. DP doesn't work. At least the way I'm thinking about it. So... Maybe the strategy is to keep putting the double bricks for... Yeah, so this is the wrong strategy. This picture I have here is wrong. Yeah. So maybe the strategy... Yeah, so strategy is not so simple. I feel like there should be some heuristic to calculate, but basically you want to add a brick, you want to add something to the smallest number first. So there's two things you can do. One is, let's say the smallest number is 1, and then 14, and then 14, and then 15. So there's two things you can do. One is you can use use cos2 to increase this and this by 1. Or you can use cos1 to increase just this by 1. So I think cos1 will be better if the numbers are very close by. Because when you do cos2, so when you do cos2, what happens is, hold on. Okay. So 1, 14, 14, 15. If you do cos2, this is the first action is always cos2. It's definitely cos2 because this guy needs to go up, right? So there's no reason why you shouldn't increase him by 1. So the second action is also always cos2. So now this is going to be 3, 15, 15, 15. Okay? So now you have to think. Either you do cos1 all the way and you bring this 3 all the way up to 15, or you do cos2 and you increase this. But that will mean that, but the problem with doing that is that will mean, all these other guys have to like if you do a cos2, you increase this by 1 and then this by 1, that means that these two guys have to go up also. So even though this cos2 is cheaper, is it worth it or not? That's the question. So in this case, it's worth it because this 1 has to go up a lot of times. And if you just do cos1 all the way, the cos1 is too expensive. So increasing the height here is not a problem. Yeah. Yeah, I don't know. I'm kind of stumped. Yeah. Max 21 will give you, is optimal, will give you 20 costs. Yeah, that's correct. I'm also tired. So it's actually it's in the morning for you guys, it's like 10 o'clock. For me it's midnight. So I'm very sleepy. It's midnight here in USA. So I'm kind of sleepy. I'm gonna think about it a little bit. So greedy, so greedy is, I think people are talking about question 3 for greedy. So question 3 is you use a GCD. So you can use greedy in question 4, it will fail on this exact problem. This 1, 14, 14, 15. Yeah. So yeah. Okay, so is system design important for fresher interviews in big tech? So that's a good question. I can tell you that for fresher interviews, probably not. So system design becomes more and more important as you become more senior. So because as you become more senior, you're required to vet architecture. So you're required to know how, not just programming in the small, like algorithms and data structures, but programming in the big, right? Figure out how the sort of big pieces of the system fit together. So system design is increasingly important as you become more senior. For fresher, honestly, when I was interviewing for like first year college fresh grads for Google, most of the time we didn't even ask them design questions. So if you have somebody with like 3 to 5 years of experience, then yeah, you get a bunch of design questions. For fresh college grad, normally no. Yeah. Yeah, I'm also gonna give up on, okay. So I'm also give up on question 4. Yeah. Yeah. Hopefully somebody can solve it. Somebody can show us the way, show us how it's done. Yeah. Let me so we have ideas for question 3. Yeah, I'll go through question 3. So question 3 is very weird. Question 3, people use GCD. And GCD, I still feel is wrong because, somebody pointed out in the chat, there's an example that doesn't make sense. But it got accepted, right? So maybe we're all not understanding the question. But maybe the question itself is wrong. So give me 1 minute to get some water. I'm going to come back and we're going to go through all 4 questions. I managed to do 3 questions. Hopefully you guys did better than me, right? Oh my god, look at this. 20 minutes. Normally these like geniuses, they finish in like 10 minutes. Yeah. So if they took 20 minutes, maybe it's a bit hard. I couldn't solve question 4. Give me 1 minute. I'll come back. I'll drink water. I'll come back and then we'll go through all 4 questions. So hang on tight. Yeah, I feel like I have a guess for question 4, but I don't think I know what the answer is. Okay, all right. So, let me do my usual spiel. First of all, happy Star Wars Day. May the 4th be with you. We are discussing solutions for LeetCode Weekly Contests 396. Jump to specific questions using timestamps in the video description. If you enjoy LeetCode content, make sure to check out the rest of my channel for problem solutions as well as solutions to all question 4s in previous contests. Like and subscribe to stay up to date on new videos. As usual, guys, if you be so kind to throw me a like and subscribe, it actually helps a lot. It does help a lot. All right, so let's begin and go through each of the questions one by one. And I hope that everybody had a good time and everybody managed to do as many questions as you wanted. At the end of the day, it says the competition, but the competition is not important. The learning is the most important. Okay. Question 1, valid word. A word is considered valid if it contains a minimum of 3 characters. It consists only of digits, uppercase and lowercase English characters. You don't have to have all of them. At least 1 vowel and at least 1 consonant. You are given a string word. Return true if the word is valid, return false otherwise. How do you do this? This is a very long and complex question, but this is a standard kind of question. This is the kind of question that you should be able to do in your sleep. Alright? This is a very, very standard programming question. What you need to do is basically just follow the instructions. You want to test if the word is valid. So first thing to test, make sure it's valid. Minimum of 3 characters. Check the length of the word. Your language might differ. In Python, it's just lang word. In Java, it's like word.length. Right? Next thing, do a for loop. Go through every letter. If the letter is not an alphabet or is not a digit, then return false. Next step, check if it's a vowel, then has vowel is true. If it's a consonant, then its consonant is true. Then finally, you return is vowel, has vowel and has consonant. Right? So all you have to do is to check that it has at least 1 vowel, at least 1 consonant, and during the for loop, you check that there are no characters that are both not alphabet and not 0 to 9. If there are, then you return false. So how do you check whether something is a vowel? This is very language dependent. Probably what you need to do is to have a list of vowels and then check whether that character appears in the lists. So in this case, I use to lower to force this to be a lowercase character. This is something you can do in Java also. So in Java, you probably have to do a find or index of. Okay. Any questions for question 1? I think it's fairly straightforward. Okay, I see some questions. Sorry. Chill, only 240 people able to do question 1? No way. I don't think that's possible. It's probably 24,000. Was the same for everyone? There was only one confused. Consider all. Yeah. Yeah, so the thing about this is you in competitive programming as well as in real life, just write it and then run it and see whether it works or not. So here you have a lot of useful test cases. Test cases will tell you which ones work and which ones don't. Okay. So question 2. Minimum number of operations to make word k periodic. Yeah, show 4. I don't have 4. Sorry, as Vashif. I think you spend most of the contest waiting for 4, but I'm sorry. I also didn't manage to solve it. Maybe next time. Or maybe you can think of the answer. And share with us. Okay, so question 2. Minimum number of operations to make word k periodic. So let's define this first. What does k periodic mean? You're given a word length of a string word of size n, an integer k such that n is divisible by k. So what you want to do is to pick 2 indices I and j that are divisible by k, and replace the substring of length k starting at I and the substring of length k starting at j. This is a lot of words, but the way to look at this is look at the things that are a little bit unusual, right? So this thing says I and j have to be divisible by k. Okay, so in this example, if k is 4, then I and j can only be 0, 4, and 8. 0, 4, and 8. So essentially, what it's doing is that it's breaking up the string into partitioning into small substrings, each one of length k. And then what do? Let's see what else it says. It says your operation, each operation is replace the substring of length k with the substring of length k starting at j. Okay, so you basically, first step, you divide this LeetCode leet into leet code lead. You divide it into 3 words. There are only 3 places where I and j can be. So you basically you divide this string. You don't want to think of this string as a long string. You want to think of this string as an array of substrings, each one of length k. So you can calculate that already. You don't have to wait. You break up this long string into substrings. In this case, there are 3 substrings, each one of length k, length 4. Okay? So what you want to do next is you then want to see, let's say I have LeetCode and lead. How many operations do I need in order to make them all the same? Well, how to calculate that? Well, the best way is just find the one that's the most common. Lead appears twice, code appears once. So the easiest way is just replace all the non-leads with lead. So there are 2 leads. There are 1 non-lead. So the answer is going to be 1. 2 minus 1, 1. So same thing. For this lead, co-lead, k equals to 2. Your substrings are going to be et, co, le, and et. Right? There are 5 of them. Which one is the most common one? Well, le and et each have 2. So just pick one of them. Let's say you pick le. There are 2 le's and there's 3 of everybody else. So the answer is going to be 3. You have to copy this le into all the other positions. So how do I know there are 3 of everybody else? I take the length of string. I divide it by k to get how many substrings there are. Over k minus the frequency of the most common one. Okay, so that's how you do it. And I'll show the code. Yeah, this one is quite straightforward. Any questions? Let me read the questions. Yes. Vashif, you solved 3 within 3 minutes. Couldn't solve hidden test cases of all. Yeah. Yeah, well, good. You know what? Good job. I am looking forward to seeing you next week. You seem to be really good at this. So that's great. Satyam Raj, I was able to do 2 less than 1. Second was described in a better way. 3 is binary search. So what data structure you use for second? Hash map. So I didn't use hash map at all. I just, oh yeah, I did use hash map. Sorry. I did use a hash map. It's a frequency counter. You use KMP to match blocks. KMP will be used for sufficient. I don't think you need to do that because you know the blocks. You know the blocks already. I don't think you need KMP. KMP is for like substring matching. So you know the substrings already. They are fixed. Yeah. Yeah. 20 minutes of because of anxiety? Yeah. So you and me both. So here's the thing, if you imagine yourself, next time you do a coding interview, you will be more anxiety. You'll be even more anxious. So you need a way to like calm down. I have problems with that also. Yeah, so you just use a hash map. So I just use a hash map. I basically break it up into words. So each word is k of length k, and I just look it up in the hash map to see if that increased by 1. So that's what this part is doing. And then I find the highest in the hash map. I actually don't have to do this. I can add the highest to here. This is actually wrong, but doesn't matter. And then I just take length divide by k minus highest. Okay. Okay, cool. So let's see any other question. Yeah, you can use KMP. KMP is string matching, right? Is find the greatest common substring. I don't know if you actually need to do that because you know the strings already. They're all of length k. So I don't think you need KMP. Okay, so question 3. Question 3, very controversial question. people are complaining about this, including me. I want to see if people are complaining on the forum. Discussion. Destroyed my confidence. Okay. It's destroyed my faith in LeetCode. You're given a string S, which is known to be a concatenation of anagrams of T. Return the minimum possible length of string T. An anagram is a word or phrase formed by arranging letters. Basically, anagram is the word with its letters mixed up. Okay, so for instance, A, B, B, A. So A, B is and B, A are anagrams of each other. So T can be B, A. So A, B, and B, A are both anagrams. So S is a concatenation of multiple anagrams of the same word. So you want to know what's the smallest possible word. Is it guaranteed that it will always be a concatenation of some anagrams? Yes, it is. Because if T equals to S, it will always work. Right? If T is S, it will always work. Except that you want to find the smallest possible T. So same thing here, C, D, E, F. The only possible T is C, D, E, F. So T has to be equals to S for this to be an anagram. So and it's only one concatenation. Yeah. So this is how it's gonna work. Okay. So the way people ended up doing it is using GCD. I'm gonna explain how GCD works first. I'm gonna explain why I don't think this is correct. And I'm gonna explain what I was trying before. Okay? So think about a long string, right? Let's say A, B, B, A, B, A, C, B, A, B, A, C, C, B, A, B, A. Okay? Let's say a long string like this. You know that this long string is a concatenation of multiple anagrams. What do you know about anagrams? You know that anagrams, all anagrams of the same word has the same number of letters in as the original word. So for example, if T equals to A, B, B, A, B, B, C, it has 2 A's, 2 B's, and 1 C. Okay? All anagrams of T have 2 A's, 2 B's, and 1 C. That's how anagrams work. How would I use that information to help you? Well, one way it can help you is the following. You start by counting all the possible, all the frequencies of letters in S. So for instance, in this example, you have A, you have 6 A's, you have 6 B's, and you have 3 C's. Okay? So if you have a string with 6 A's, 6 B's, and 3 C's, and you know that this is a repeat of some K copies of the anagrams of T, okay? If you know that this S equals this long string, and S has 6 A's, 6 B's, and 3 C's, and it's K copies of T, of anagrams of T. Each anagram of T has the same number of letters. Okay? What's the possible values of K? Well, the only possible value of K has to be 3. Because that's the only number that divides all these 3 numbers evenly. If K is 3, then T will have 2 A's, 2 B's, and 1 C. K cannot be 4. If it's 4, you cannot divide 3 C's by 4 copies of T. And you cannot divide, and K cannot be 2, because same thing, you cannot divide 3 C's, you cannot distribute these 3 C's evenly among 2 copies of T. So the only possible number for K is going to be 3. Okay? Does that make sense? Yeah. So that's the only possible number of k. Okay? So what happens next is you can, given the number, given if you know k, then you will be able to deduce t, right? Because your job is to return the length of t. So if k is 3, if k is equals to the GCD of all the frequencies of all the letters, then t, the length of t, is equals to simply the length of s divided by k. Does that make sense? Yeah. So this is, so if you write this code and you run it, it will pass the test. But the thing is, I don't think this is correct. Why I don't think this is correct? Because let's say you have another example. If S is A, B, 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 okay? There are 4 A's and 4 B's. The GCD is going to be 4. So according to the math, K equals to 4. And you're supposed to be able to find K copies of T prime. But this is not correct. This is not correct. If you divide S into 4 substrings, these are not anagrams at all. Yeah. So this is not correct. In fact, if you take this example, right? A, B, B, A. You just add A, B, B to it, you get the same problem. If you just do a frequency number count and you do a GCD, you end up with 4 again. And this is not correct. Because you don't have 4 copies of T. You can only have 1 copy of T. In fact, oh, sorry. The answer here should be 2, not 4. So, yeah. So, I don't know. Yeah. I don't know what. Yeah. I don't know how they end up with this. But I do have what I think should be the correct way to solve it. Here's what I think the correct way to solve it. Let me look at chat. Yeah. 2 is answer. Yeah. So I think the test case is wrong. Even though if you use GCD it gets accepted, but I'm convinced that the test case is wrong. Okay. So here's what I think is the correct way of solving it. Okay. I'm going to use a lot of real estate here. Here's what I think. I haven't finished this, but I believe that this is the correct way, but it is much slower. It's much slower. So basically, what happens is the following. You have a long string. Let's say you have A, B, B, C, C, A, B, B, A, B, C, B. Okay, a long string. You want to know what is the pattern that repeats, right? So what I'm going to do, my strategy is I'm going to have 2 pointers. One is, I call this the T pointer. And at first, it's going to be 1. And then I have a current pointer. And the idea is I want to count. I want to move T to the right. And as I move T, I'm going to increase current by multiples of T. And I want to test whether T is a legitimate repeatable how do I say? If like the substring that ends with T is a legitimate anagram candidate. So at first, my first pointer is T. Okay? So T will be equals to A. Current is equals to B. And then immediately I realize that that this current has one A and one B. Okay, I shouldn't write it this way. Has one A and one B. So T cannot be this. So I have to move T to here. And so now T has one A and one B. So now this looks correct. Current is equals to here. So I'm going to move this current again. Because T is going to be, T is now 2. C has to move my multiples of 2. So my next position for C is going to be here, C. And at here, I have 1A, 2 B's, and C is 1. So again, this T is not here. That's wrong. That's invalid. I have to move it again. I'm going to move it here. T is now here at 3. Okay? But what I realized is that, so 3. So because T is at 3, I'm going to move C to the next multiple of 3, which is 6. Let's use a different color for C. 3, 4, 5, 6. I'm going to put C here. 6. And at C, at 6 has 1A, 1B, 2 C's, 2 A's, 2 C's, and 4 B's. And so this is wrong again. So again, I know my T cannot be this. So I have to move my T again. So essentially, I'm testing my each T. I'm testing each T as I go along. T is now 4, and C will have to go to 8. I'm testing each possible value of T as I go along. And notice how my pointers always go to the right. They never go backwards. So I believe this will be ON time. So now C is at 8. So what happens when C is at 8? When T is at 4 and C is at 8, T has 1A, 2 B's, 2 B's, and 1 C. C has 2 A's, 4 B's, and 2 C's. Oh, hey, this is correct now. Okay, let's keep going. Let's move C all the way to the end. And now it has 3 C's, 3 A's, 6 B's, and 3 C's. And it's still correct. And because C is now at the end, I'm going to return this T, which is 4. So that's how I think you can do it. I think that's how you can do it. If you want to do it the proper way. And and this algorithm should be ON time. This should be ON time because the pointers always move to the right. They never go backwards. So it's going to be ON time. And this would, this will give you the right answer. If you have like A, B, 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 then, you will not, this will give you 8, which is the correct answer, rather than 2, which is wrong. Okay. Let me see if there's anybody in the chat. Yeah, I think people, yeah. No question in the chat. Great. So, the last one, I don't know what the answer is. I think it's some dynamic programming question. Okay, let me read the question first. Question 4. This is a difficult question. it is worth 8 points. Minimum cost to equalize array. You're given an integer array nums and 2 integers cost1 and cost2. You're allowed to perform either of the operations any number of times. So either you use cost1 and you increase one number by 1, or you use cost2 and you increase 2 numbers by 1. Okay? Now you might be thinking, why would I ever use cost1? Well, there's 2 reasons. One, if cost1 is cheaper than half of cost2, then, well, of course you use one cost1, right? And the other reason is if cost1, if you only have one number that you want to increase. So for instance, 4 and 1, you only want to increase one number. So you have to, basically you use cost1 3 times to get this up to the same number of here. Okay? So how do you want to do this? So I can show you what I initially did. I just did a greedy approach. I sort them. And I say, let me show you how the greedy approach works. Okay? Think of them, sort them first, and now the numbers form a staircase, right? You can think of the numbers as, you sort the numbers from smallest to largest. And then the idea is you want to bring all of the numbers to be equal to the largest number. That's the greedy approach. And how will greedy work? Well, for greedy, you're going to lay a cost1 here until these two are the same level, and then you spam a bunch of cost2s to make them same level. And then you spam a bunch of cost2, and then you cost1, because this is 3, right? This is an odd number. And then you keep going, right? So last one you have like cost2. So this is the greedy algorithm. Okay? So greedy will pass all the 3 test cases here. And this is what some people try. But the greedy algorithm doesn't always work. And so this is what I try also. Yeah. This is what I tried also. So this is a very simple greedy algorithm. But greedy doesn't work. When does greedy not work? I'll show you guys. Okay? This is an example of greedy not working. So this is 1, 14, 14, and 15. If I do a greedy approach, I want to make all of them 15. So I'm just going to greedily add a cost2 here to make this 15 and 15. But now this cost1 is stuck. I have to add this this first one is stuck. I have to add a bunch of cost1s. And this is very expensive. This is very expensive, as it turns out. Okay? In this case, cost2, in this particular example, cost1 equals to 2. Cost2 equals to 1. So in this particular case, because you lay 14 bricks here, the 14 will be 14 times 2, which is 28. This is really expensive. So instead, there's actually a better way to do it. The better way is to use a bunch of cost2. So you will have a cost2 here and here. And then you have another cost2 here and here. And then you have another one here and here. And then you have another one here and here. And so on and so forth. Now, this one, weirdly enough, this solution requires you to go even higher than the highest elements. You end up having to sort of increase more, like the total number of numbers that you have to increase is actually really high. But it's actually cheaper because cost 2 is so much cheaper than cost 1. So even though you're essentially laying more bricks, the cost is actually lower because cost 2 is cheaper, is so much cheaper than cost 1. Yep. So this is the trick here. So I don't know what is the best way of calculating this. I think it has to do with like, when you want to decide whether you want to. Yeah, I don't know. I have to think about it a little bit. I think it's still a greedy approach. So you want to lay the first. You sort of lay the first brick with the, like, you want to keep this like a sorted array, and any one time you want to lay a brick on the smallest one. Okay, and when you want to lay a brick on the smallest and the second smallest one. If your second smallest is the same height as the highest one, then you have to decide: do you want to use a level 1, just a cost 1 brick, or you want to use a cost 2 brick? And I think the way to decide is to count how many columns there are. Yeah, in this case, it's actually cheaper to lay the cost 2 bricks because, I'll have to think about it a little bit. Anyway, I have to think about it a little bit. I didn't manage to finish this, unfortunately. I think I can. I'm going to stay up and try and get it done. If I do, maybe I'll release a video if that's what people want. Either way, that brings us to the end of today's contest and problem discussion. I hope that everybody had a good contest. I hope that all of you learned something today and ended up a little bit better than before. For those of you who are left in the chat, thank you for watching. Once again, I would appreciate your support, like and subscribe. And I will see all of you next week. So, bye-bye.